Okay, good afternoon. I'm P.C. Shaw from the School of Life Sciences, the Chinese University of Hong Kong. Today we have the 70th anniversary lecture of New Asia College and also the Ying Kok Yung Lecture in Life Sciences. This lecture series is made possible by the generous donations from the Ying Kok Yung Memorial Fund. And we are also very happy to collaborate with the Hong Kong Science Museums so that we have the popular lecture hosted in this venue. Today we are honored to have Sir Richard J. Roberts from New England Biolabs to give us a talk on the genetically engineered, genetically modified organisms. Sir Richard Roberts was born in Derby, Great Britain, and he got his undergraduate degree in University of Sheffield and later a PhD degree in organic chemistry there. After obtaining his PhD, Sir Richard did a postdoc at Harvard University. He also stayed as a guest in Frank Sanger's lab, the scientist who has got 2 Nobel Prizes, and developed interest in nucleic acid sequences. In 1972, Sir Richard started working at Cold Spring Harbor Laboratory in New York. There he discovered split genes in higher organisms, and this won him the Nobel Prize in Physiology or Medicine in 1993. Since 1992, Sir Richard has been working as a research director in New England Biolabs, which is a molecular biology reagent company that sells products all over the world. And I'm sure that every research lab in Hong Kong and elsewhere use this product. He is currently leading a campaign that includes 131 Nobel laureates who support the use and inherent safety of GMO techniques for improving plant varieties, especially those needed by the developing world. Without further ado, let's welcome Sir Richard.
Thank you. Well, thank you. It's very good to see so many young people here. This is terrific because for many people who are against GMOs, they tend to be old. But I found that the young people are much more receptive to new technologies. So what I want to do during the course of this talk is to give you some idea of how I got involved with this issue of GMOs. I'm not a plant biologist. I'm a molecular biologist. I work on bacteria. I got involved quite by chance. I went to a symposium in which I heard a lot of plant people talking. And as a result of that, I took on this campaign. I started getting Nobel laureates interested in the campaign. And basically, the message is that GMOs are safe. If anything, they're safer than plants that have been produced by traditional methods. And I hope to convince you during the course of this talk, first of all, that they are safe, and secondly, to give you some idea of why there has been such a widespread opposition to them. Totally non-scientific, I should add. Now, I want to start by talking about how I got involved. So, gentleman on the left, here, if this works, does this work? Yeah, this gentleman here, this one here, is Mark Van Montague. He's a Belgian. He's a very good, very old friend of mine. And he was the person, along with Jeff Shell on the right and Mary Dale Chilton at the bottom, who figured out how bacteria naturally transfer DNA into plants. And we now know that this is actually something that's quite common. It's not something that's unusual. But at the time, this was the first demonstration of what was going on and what we now know as genetic modification. He had a symposium to celebrate his 80th birthday. And at it, there were a large number of plant biologists, and I got invited just because I was an old friend. And I spent the day listening to plant scientists talking about the work they were trying to do and how difficult it was to do this work in Europe because of the anti-GMO people. People would get up and give talks about this GMO technology, and the antis, mainly Greenpeace and the Green parties, would demonstrate outside the hall. They would demonstrate within the hall where someone was talking, and they just made life very difficult. They tried everything they could to stop funding for this kind of work, and they even went so far as when plant scientists were trying to plant their crops, the anti-GMO people would go out and would burn them. Many examples where people went out and burnt them. And by the time the day was over, I was very concerned about what was going on. And one of the problems was that the anti-GMO people would always accuse the plant scientists of being untrustworthy. You couldn't trust anything they said because they were funded by agro-businesses of one sort and another. And the reason they were funded by agro-businesses is because, in general, governments have spent very little money supporting plant research. Because I'm not a GMO person, I don't work on GMOs, I don't work on plants, and I'm not funded by agro-business, I thought that this was perhaps a good opportunity to have someone who, in general, people listen to. I have to say this is just because I won a Nobel Prize. I used to talk a lot before I won it, and people maybe listened politely, but they didn't really listen to what I was saying. And after I won the Nobel Prize, all of a sudden I find they're listening to what I say. So I thought maybe this was a good opportunity to take advantage of this. And it turned out the following day after the symposium, I'd been invited to talk to the European Commission about the future of health. Well, I don't know a lot about the future of health, but one can always think of things to say. But I decided I was going to change my talk, and the night before I spent a lot of time putting some slides together about GMOs, and I decided I was going to talk to the European Commission about GMOs. And the argument was that if you live in the developed country, then the kind of medicine you need is pretty different from the kind of medicine that people in the developing countries need. If you live in Africa, you live in many parts of India, many parts of South America, you're hungry at night. Some 800 million people go to bed hungry every night. And for them, food is medicine. And so this was the message that I tried to give to the European Commission. And I talked about some of the things that I will talk to you about. But what I discovered was that after this talk, there was an Italian senator, a lady who was in the Senate of the European Parliament, who came to me and said, I was overwhelmed by this talk, that before I heard you, I was anti-GMO. I was totally opposed to them. And having heard you talk, I've changed my mind completely. And now I think what you're saying is very good, that GMOs are good, we need them. And in particular, the developing world needs them. And a number of staff members of other senators also came up to me afterwards and said it was very refreshing to hear this talk in Europe about this subject, because people had really stopped talking about it. It had become a non-issue because it was so politically sensitive. So what I did was to decide that after that, I perhaps would organize a Nobel laureate campaign. I'd organized a few campaigns previously in which I'd managed to get a lot of Nobel laureates to support various causes. And I thought maybe this was a cause that they would be interested in too. So I started talking to some of my Nobel friends and asked them, is this something you would be prepared to support? And quite a lot of them said yes. And over the course of a little over a year, I gathered quite a lot of people. I got more than 100 Nobel laureates who all agreed that GMOs were okay. This was not something that one should be frightened about. So in June of 2016, I started the campaign. I organized a press conference in Washington. We sent a letter to all of the anti-GMO organizations, but mainly Greenpeace. We also sent a letter to the head of every country's delegation to the United Nations. And basically, the letter said, why don't these green parties look at the science, listen to the science, and just admit this was an issue they got wrong? You know, all of these organizations that come out in campaigns for this, that, and the other, sometimes they get it right, but sometimes they get it wrong. And for Greenpeace, there are many things that they've done right. They're trying to protect endangered species. But this is just one issue that they got wrong. But they're not prepared to change their mind, and during this talk, I will show you why. At the moment, we have 142 Nobel laureates who've all signed on to this letter about the safety of GMO technologies. 142. The anti-GMO people, they don't have any Nobel laureates supporting them. In fact, almost nobody supports them who has a good scientific background. I like the cartoon on the right, which was put out by a cartoonist who writes for a paper in Iowa, which sort of shows you what is happening. If you've got plenty of food and you eat well every night, it's all fine to be against GMOs. But if you're a little boy in Africa who is hungry, he just wants the food and doesn't really care whether it's GMO or whether it's non-GMO. At the bottom here, supportprecisionagriculture.org is a website. It's the Nobel laureates website about this issue. There's names of all of the Nobel laureates and the prizes that they won when they won them. There are a lot of other people who've signed on and said, we support you. We have many thousands of people who support us. And there's a lot of general information about GMOs. And I would encourage you, take a look at the website, have a look and see what is there. And if you agree at the end of this talk that you too are in favor of GMOs, then join us, sign on, put your name on, and talk to people about this. Now, for the last 10 or 12,000 years, agriculture has been something that everybody needed. And agriculture got started when the early hunter-gatherers realized that instead of going out into the forest and trying to find edible plants, they could take these plants, grow them in their backyard, and start smallholder farms. And this was really the start of industrialized agriculture. Nowadays, smallholders still continue to produce food for themselves, but people like you and I who live in big cities, we don't have enough land to grow our own food. We have to go to the supermarkets in order to get it. And the supermarkets have to rely upon big agro-business, big farms, big agricultural concerns in order to get the products that they're going to sell in the supermarkets. Now, what happened was that as these farmers, the smallholder farmers, were growing crops in their backyard, they realized that some crops grew much better than others. They also realized that you could make crosses between crops, and in this way, if you had one plant that maybe grew very tall and another one that was not very tall, and you wanted everything to be tall, then you would go out of your way to make a cross and try to get this gene, the genetic basis of this tallness, into the plant that you've been growing. This is exactly the same way that humans make babies. Okay? We get a man, we get a woman, and they produce a child, and that child has the traits of both the mother and the father. But in this case, we typically just have a baby and we don't try to modify it specifically. But with plants, you can do that. You can make hundreds of crosses and predict and eventually get the crops that you want, the crops that you need with a specific trait. Here's an example of something that was carried out in Central America. The Mayans got started on this and several other cults. On the left is the precursor of corn, sweet corn, that you buy in the supermarket. Looks pretty good, loads and loads of grain. But the original plant from which this came is called teosinte, and it was this rather scraggy-looking plant that produced very small grains. And over time, the Mayans and other Central Americans figured out how to make crosses that would eventually produce corn that looks like this. This is genetic modification. There's nothing terribly special about it. You cross a male and a female plant, and eventually you can get ones that produce the foods and the kinds of plants that you want. This is a slightly more scientific explanation of what's going on. So if you want to cross two plants, you take what we call the elite variety that you've been used to growing and that you grow in large quantities, and then you decide you want something that is a little better. Maybe you want something that produces more grains than the one that you started with. And so you find another plant that is related to it that does exactly what you want, but maybe has other properties you don't want. You make the cross, and the first hybrid will have a mixture of the two genetic components. Half the genes will come from one plant, half from another. And let's say the gene that you're looking for is represented by this blue ball. What you then want to do is to get rid of all the genes that you don't want, all the yellow ones, and eventually get to a point where you end up with something that is mainly all original genes plus just this blue one. But of course, by traditional methods, it is very difficult to do that. Imagine you've got 1,000 genes, you put 500 in the first cross, and then 250 in the second, and 120, and you have to keep crossing and crossing before you can get rid of all the genes that you don't want. And this can take a long time, typical crops. Maybe if you're lucky, you can get 2 crops a year, but very often you just get 1 crop a year. It can take 20, 30, 40 years sometimes in order to get the crops that you want. And then when you've got it, unfortunately, there's always a few extra genes that are there that you were not able to get rid of, and usually we don't know what they are, we don't know what they do, but we've been doing this for so long that everybody thinks it's okay and it's safe. Now, the other thing you can do is if you can't get the desired product by crossing, sometimes you can just make mutants. Let's say there's a gene you want to get rid of. You just make mutants. You irradiate the plant, use X-rays to radiate the plant, or you use ionizing radiation to ionize the plant, or you can put in chemicals and make chemical mutagenesis. And in this way, too, you can also sometimes get a desired trait into a plant. But of course, as soon as you start to make mutations, you don't just make it in one gene, you make it in many genes. And so in this way, you end up with plants that have a lot of mutations. And we don't know what they are for the most part. We don't have good techniques to find them, or at least we didn't. We do now, but we didn't. However, what Mark Van Montague and Jeff Shell and Mary Del Chilton discovered was that there was a bacterium called Agrobacterium tumefaciens that had in it a plasmid, a small piece of DNA, and this bacterium had figured out how to move that DNA into the plant, into the genome of the plant. And in this way, basically what it did was to take this piece of DNA with a gene and transfer it into the genome of the plant. We now know that this is something that's relatively common, but what Mark realized very soon was that, maybe instead of using the gene that was in the bacterium, maybe we could take a gene that we wanted to put into the plant. And so we can take the plasmid, replace this gene, which is normally in the plasmid DNA, with the gene that we want to put into the plant. Maybe we want to put a gene that will make the plant grow more quickly, or one that will make the plant resistant to drought or resistant to flooding, or maybe it will make more grains, or maybe it will grow taller. And in this way, we can actually precisely engineer the plant in a way that is not possible by traditional breeding. We can take one gene, put it into the plant, and have it have the desired properties. We know which gene it is. We usually can find out very easily where it's gone. And in this way, we can be very, very precise about what we do. On the left is the conventional breeding, the typical breeding that I described previously, and on the right is the precision breeding that Mark van Montague and his friends came up with. And the anti-GMO movement, the Greenpeaces of this world, they say, well, this is safe because we've been doing it so long, even though it's not very precise, but we've been doing it so long it must be okay. But this, they said, was dangerous. This is the precise method where we know what we're doing. Frankly, it just doesn't make sense. But I will give you even more reasons why it doesn't make sense. But let me give you an example for those of you who may got a bit thought the genetics was a bit complicated here. Let's say I want to move a GPS system from one car to another. You know, you've got an old car, it's got a GPS system in it, you want to move it into the new car. So what do? Do you take the two cars apart, mix everything up, and then select the one that has the GPS system in it? No, I don't think you do that. I think you take the GPS system and you unplug it and you plug it into the new car. That is the GMO method of making plants. It's all it is. You take one gene, it could be a GPS gene, put it into the new car. Greenpeace tells you this is terribly dangerous. And not only that, they say if you take the GPS system from an airplane, maybe the car will fly. I mean, this is arrant nonsense. I mean, it is clear to anybody who has any sense of logic that this is nonsense. And yet, Greenpeace have made tremendous mileage out of selling this story, that if you take a gene from something that's unrelated to the plant you want to work with, that this is going to cause all sorts of problems and make major changes. And I think we all know that if you wanted a car to fly, you've got to do a lot more than put a GPS system into it. What's important here is not the method by which you do something, but what's important is the product. Okay, so if I take a gene, put it into a plant, I want to know whether the new plant is safe, whether it's okay to eat it, whether it's poisonous. I want to do some tests. Now, what's happened is because of the opposition to GMOs, those tests that are now called for are so rigorous that it costs a fortune to do them and to bring a GMO plant to market. But if you make a plant by the traditional methods, it's very cheap. Everybody says, oh, it's automatically safe. We think it's okay. There's no special regulations. And yet, if you look at the history of plants that have been produced by traditional methods, they have plenty of problems because they're not tested. What usually we do is we grow them, sell them, and then wait until there's a problem, and then we stop selling them. We test them on people, basically, which is not the right way to do things. Whenever you make any kind of modification of this sort, if you're going to have regulations, they should apply equally to GMO plants and to regular plants. It makes no sense to do anything else. Now, are all plants safe to eat? Is it okay to eat any old plant that's just been growing out in the backyard, or one that you've made by traditional methods of breeding? Well, of course, the answer is no. One thing you have to realize is that plants have a problem. You know, if you or I see someone coming along to try and eat us, we run away. We have legs. We can get away from these things. If a lion comes, you run off as rapidly as you can. Plants can't do that. So why is it that there are plants? Why do they even exist? Because we know there are insects that love to eat them. Many things like to eat plants. How do they get away from this? They can't run away, so what do? They produce insecticides, they produce pesticides of one sort and another. And so pretty much every plant that you eat has chemicals in it that are produced specifically to stop pests from eating them. If plants didn't do this, there wouldn't be any plants. They'd all be eaten. So I want to use this case of a nice paper that was put out by Bruce Ames. Bruce Ames is one of these people who's been very interested in compounds that cause cancer. If you look at a lot of plants, show parsley, celery, mushrooms, cabbage, they have within them, they produce a compound, many compounds, but one of them is called methoxysorolin. Methoxysorolin is quite carcinogenic. And celery, in particular, down here shown on the right, has quite a lot of it. To a point where the ladies who used to be cutting up celery to pack it for supermarkets, so they cut it up into pieces, put it into supermarkets to sell it, they would get the juice of the celery onto their hands, and they would get a contact dermatitis as a result of that, and sometimes they would even get skin cancer as a result of that because of this compound, methoxysorolin. Okay? There's a very nice paper here by Seligman et al., in which they did an epidemiological study of this and looked at a lot of people who'd been handling celery. If celery were a GMO, you would not be allowed to buy it. It would be prohibited because the regulations for GMOs are so strict, it would not allow this to pass. But it was never tested because you don't need to test things like this. And in point of fact, you don't need to worry about celery because the amounts that you typically get when you eat it are very small, and your body knows perfectly well how to deal with it. So, one of the things that the science tells us is that basically GMO-derived organisms, plants, are safe. And we also know that in Africa, South America, Asia, they need better crops. If you look at what has happened in the agricultural business, is that big agro-business has focused on the plants that we eat. Plants that they eat in Europe, in the US, in Japan, because here people will pay to buy these plants, will pay to buy the products. They have lots of money, and so the big agribusinesses are interested in how we can make as much money as possible. But in Africa, cassava, manioc, these things that we don't eat very much in the West, big agribusiness had no interest in them because they couldn't make money in Africa because there's just not the market there. People don't have the money to pay for improved crops. And so big agribusiness focused on all of the crops that we eat in the West. And as a result of this, the crops that are typically grown now by the farmers in the US, in Europe, have been improved to a point where they produce large amounts of the yield. Let's say it's maize, they produce a lot of the grain. And they have been slowly improving these over the years to a point where they may be 5-10 times better than the original plants that were being grown. But you go to Africa where they're growing many crops, manioc and so on, there's been no improvement there. There has been no plant breeding to try to improve the yields, to try to improve the nutrition, to try to improve the way that these will grow. And so you have to ask a question, well, if the GMO method can allow you to improve crops much more rapidly than by crop breeding, why would you not do it? Why would you not want it? For Europe, they don't need GMO crops. If you meet a European, you rarely see a thin one. But you go to Africa, you can see plenty of thin people. Europe has plenty of food. The US has plenty of food. Even here, we have plenty of food. Food is not a problem. But in much of the countries where these 800 million people go to bed hungry every night, they don't have access to these better crops. So why would you not want to give them access? Why would you not want to let the local scientists make the improvements in these crops? Well, I think you all know that every time you want to know why people do things, usually money is at the bottom of it all. And in this case, it's not just money, it's politics too. Europeans didn't want the US food companies to take over their food supply. In fact, Europeans have been against Monsanto for the longest time, and Monsanto became really a dirty word in Europe, but it became a dirty word in many places. I'm not a big fan of Monsanto. I think the way in which they've tried to push their products is not particularly good. And they made a mistake because on the one hand, you can't ban Monsanto in Europe, which is what many people would have liked to do, because all the farmers were buying their seeds from Monsanto. But then Monsanto, when they started using and making GMO products, what they did was to set it up in such a way that they made a lot of money. They sold these products to the European farmers who made a little bit of money, and then they charged the consumers more. Does this sound like a good business practice? Well, obviously not. This is not the way to do things. What you would like to do would be if you're going to charge people more, you want them to have more value for their money. But Monsanto didn't do that. And Greenpeace, and in particular Patrick Moore, who was the head of Greenpeace at the time, thought here was our wedge. Here's a way to get at Monsanto. Europeans don't like Monsanto. And so we will make the argument that they're trying to sell us GMOs, and GMOs are bad. And then they came up with all these wonderful stories to scare people about GMOs. And I think you all know that it's actually very easy to scare people. You go to Hollywood, they make all these scary movies. Very, very nasty movies, The Exorcist and so on, in which people get scared rather easily. You go to the movie theater, you come out at the end, and you're looking over your shoulder to make sure that some nasty person isn't following you. It's easy to scare people. And the problem is that once you scare people, it's very difficult to reassure them that things are then okay. But Greenpeace were not interested in that. They had no interest whatsoever in trying to reassure people. They just wanted to scare them. And it worked really well. And as a result of it, many people started contributing to Greenpeace. They gave them a lot of money. And Greenpeace is now one of the best funded NGOs out there. The guesstimate is that in Europe, they get between 400 and 500 million euros in income every year, and most of it because of their support and in being against GMOs. And the best of all, when they took this route, is because Europe didn't need GMOs, there was no economic cost whatsoever to Europe. It was only Monsanto and the companies producing GMOs that had the problem. And then we get to the downside of this. So in Europe, it doesn't really matter. Okay? You don't want to buy GMOs, so you don't buy them. But you can't then claim, well, because we know that Africans and South Americans need GMOs, we can't say, well, these things are dangerous for Europeans, but they're perfectly safe for these other countries. And so Greenpeace and the anti-GMO movement then started going around visiting these countries, Zimbabwe and various other places, and convincing the political leaders that GMOs were bad. And in this way, they spread their influence around the world, and they spread it to the very countries that really need GMOs. This is a list of scientific societies, or at least the start of a list, of the academies of sciences around the world who've all come out and said, well, they see no reason why GMOs are dangerous. Many of them have come out and said they're absolutely safe. If you look down here, here's the Chinese National Academy of Science, and some 200 others around the world who've all come out and said GMOs are safe. There are two organizations that say they're dangerous. They claim to be scientific, but in fact, they're basically composed of people who are anti-GMO to start with. Many of them, like this Institute for Responsible Technology, it's run by a man called Jeffrey Smith, who produced a documentary movie trying to claim GMOs were dangerous. He has no scientific credentials whatsoever, but that doesn't bother him at all, and so he organized this society. And so all of the credible scientific societies have come out and said GMOs are safe. I want to show you a few case studies of how GMOs can actually solve problems in the developing world. One of the first real examples of someone trying to help concerns vitamin A deficiency. If you don't get enough vitamin A during the first few years of life, you run into major problems. First of all, you can go blind very easily. Your eyes don't develop properly. You also suffer many developmental defects. Your immune system doesn't work as well as it should. And the estimate is that somewhere between 1 to 3 million children die every year because of vitamin A deficiency. This compares with HIV, tuberculosis, malaria, nothing like as dangerous as a simple vitamin A deficiency. We don't have that problem. We have plenty of food that contains beta-carotene, which is the precursor of vitamin A, carrots being a classic example of this, or people will give their children vitamin A tablets to make sure that they get enough. Now, 2 European scientists, Ingo Petraikas at the ETH in Zurich and Peter Bayer at the University of Freiburg, thought they had a good solution for this. And they figured that there are many people in these developing countries for whom the prime food is rice. You all eat a lot of rice. Rice turns out to have a lot of beta-carotene in the stem, in the roots, in the leaves, but nothing in the grain. And so they thought maybe we could engineer rice so that it could produce beta-carotene, the precursor of vitamin A, in the grain. And of course, beta-carotene is sort of orangey in color. This is why carrots have their color. And so the rice itself would be colored as a result of this, and they called it golden rice. They spent a lot of time and effort to develop this. It became a reality in February of 1999. They had produced a genetically modified rice that was producing beta-carotene. Usually, when you have a crop that you've developed, let's say I'd done it by traditional plant breeding, within 2 to 5 years, you've got varieties that will grow well in the field, and you can start to commercialize it. But it's a GMO, and as a result, it ran into all sorts of obstacles. And in particular, Greenpeace went out of their way to put every possible obstacle in the way of doing this. And I think it's clear why. So one of the problems is that this is not just a food, this is really a pharmaceutical. This is something that is actually treating an illness. It's treating vitamin A deficiency. You know, there are other GMOs that are pharmaceuticals that you never hear Greenpeace objecting to. I don't know if any of you in the audience are diabetic, but if you are, you probably take human insulin. Human insulin is not made from humans, it's made from a yeast. We have taken the gene for human insulin, put it into yeast, and we grow it. It's a GMO. Have you heard Greenpeace or anybody else objecting to that? Not at all. It's a pharmaceutical. It's saving people's lives. This could too, and this was why I think Greenpeace was so opposed to it, because they thought if this comes through, it will undermine their whole case for being against GMOs. And so they did everything they could to stop it. They called it Golden Illusion. This was a brochure they produced 2 or 3 years ago. What they claim here, and what they've claimed all along, is that it's taken so long to bring golden rice out into the field and into the hands of the people who can grow it that it can't possibly work. They fail to mention that they were the people who slowed its development down. They did everything they could to stop it. I gather they're not producing this document anymore, because this year, golden rice is actually going to become a reality. It's going to be grown in Bangladesh within about 2 months. The government of Bangladesh is going to approve it they have a good variety, it will be in the hands of farmers, and I can guarantee that once they start growing it, there will be plenty of other places that will want to grow it too. You know, here's something that can really save children's lives. So, since 2002, when this could have started to be out in the field, more than 15 million children have died. Now, if this had been a case of Rwandans going off and killing children, the world would have been up in arms about it. But have you heard anything about this? Probably not. This is not something that causes a problem. But to me, I find this is a problem. This is a crime against humanity when it could have been out in the field and helping people. And this is just one example, but I think it's a particularly good one because it tells you why the anti-GMO people do the things they do and why they are opposed to the GMO things, and in particular, why they have been opposed to golden rice. I want to tell you some more stories. In Uganda, and actually throughout sub-Saharan Africa, there's a major problem with bananas. Bananas are the major, they provide 30% of the calories in Uganda. This is a really big, important cash crop for them. But there is a disease called Xanthomonas wilt. It's a bacterium that grows on bananas, and the bananas have no resistance to it. Plants die, and it's a problem. The only way you can grow bananas is by throwing huge amounts of pesticides, antibiotics, onto the banana plants. You typically need 10 to 12 treatments a year to stop Xanthomonas wilt. Now, traditionally what you would do is you would find a species of banana that was resistant to this, and then you would try to cross that into the bananas that you're growing commercially. But unfortunately, there is no banana that is resistant to Xanthomonas wilt. There's a big collection in Belgium of more than 500 species of banana from around the world. None of them are resistant to Xanthomonas wilt. However, sweet peppers, which they also grow in Africa, have two genes, and they are resistant to Xanthomonas wilt. If you take these two genes, move them into bananas, now bananas are resistant. This looks to be a very good thing. The science has been done. It looks good. Uganda, the parliament, have put together some legislation that would allow the growth of these GM bananas, these Xanthomonas-resistant bananas. And that bill went to the president, President Museveni. He is very pro-GMO. The prime minister is very pro-GMO. The minister of agriculture is pro-GMO. But when he got the bill, he sent it back to Parliament with a whole series of additions and amendments that he wanted put into it that would essentially have made it impossible to grow this banana in Uganda. Why did he do this? Because the anti-GMO people had gotten to his daughter and had gotten to his wife. And his daughter and his wife convinced him that he had to be opposed to this, and so he's now in a state where the parliament are trying to figure out what to do. Should they go against the president? Should they just push it through? What should they do? Well, you can imagine how the Ugandan farmers feel about this. They think they need these, and they do. They can't afford all the pesticides they need to keep the Xanthomonas out otherwise. Here's another rather sad case. Fall armyworm. Fall armyworm is a caterpillar, spreads rapidly, grows like mad, and likes to eat corn and maize. In the southern states of the US, they had a major problem with that many, many years ago. The breeders put in a gene into corn, into maize, that would stop fall armyworm. It's called the BT gene. That stands for Bacillus thuringiensis. This is a bacterium, makes a small peptide that kills insects. This is the insecticide or the pesticide that the organic farmers use in order to keep pests away from their crops. Okay, they spray it all over. However, they're totally opposed to putting this gene into plants, because somehow this is very dangerous. Spraying it all over the place is okay, but putting the gene into the plant is dangerous. They put it into maize, and now all the corn that comes out of the southern part of the U.S. is from a genetically modified organism, from these plants. Turns out in Africa, South Africa tested it when they had the problem and discovered that this corn grew perfectly well in South Africa. And so we know now that it grows well in Africa. You don't need anything very special. And yet, these countries, Zimbabwe, Zambia, Namibia, Malawi, and so on, because the politicians, presidents, parliaments were gotten to by the anti-GMO people, they're not allowed to grow them. And so all they can do is sit and watch these fall armyworms eat all their crops. And a lot of people are going hungry as a result of this. Bangladesh are probably at the forefront of doing something really good. A number of years ago, they took BT eggplant, BT brinjal, they call it, in which they take eggplants, the BT gene has been put in, and it has improved the yields of eggplants so much that Bangladesh now grows more eggplant than they can eat. And so they're selling it abroad. Interestingly, the farmers in Assam, in India, Assam is one of the neighboring states to Bangladesh, they had a big problem because of insects eating all their eggplants. And in India, they have fairly strict rules, anti-GMOs. And so what did the farmers in Assam do when they look over the fence and see that the folks in Bangladesh are growing huge amounts of eggplant? They said, oh, why don't you give us some of those seeds? Let us try it. And so now it's growing in Assam, even though it's banned. But these are farmers. They need to make a living. They've got to grow crops in order to live and to feed their families and to feed their neighbors. I think this is something we're going to see more of. Farmers tend to be pretty sensible. And there are a number of countries now where we know that they are growing GM crops because the regular crops won't grow. I like this story about papayas. This gives you some idea of how politics plays into all of this. Many, many years ago, the papaya plants in Hawaii were having a problem because of a virus that was transmitted by insects. It's called ring spot virus. This virus would kill papaya plants. A man called Dennis Gonsalves, who works at the University of Hawaii, developed a GM papaya that was resistant to ring spot virus. Farmers thought this was great, and so they slowly replaced most of their papayas with this new GM variety, and it grows very well. Hawaiians sell their papayas to the US. People in the US eat them. Never any concern. No one had even known that they were GMs. And then, a few years ago, there was this movement by the organic farmers to get GM foods labeled. They wanted labels on everything that was genetically modified. The idea was, they spent a lot of money on this, the idea was that if you had to test all the foods you were selling to see if they had a GMO in them, it would raise the price of regular food, and people wouldn't then mind paying a bit extra to buy organic food. Right? Money, 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 money. However, it turns out that when this idea of labeling went to Hawaii, the government of Hawaii said, terrific, and the farmers said, what? You're going to destroy our market. No one's going to buy our stuff if we have to label all these papayas as being genetically modified. Government of Hawaii thought about this quite a lot, and they were worried that they were going to get voted out of office. And so what did they do? They said, oh, we will grandfather papayas. We'll say, don't need to label them because they were made so long ago, and you're only going to have to label new stuff that is GM. This is politicians for you, right? I don't need to go much further, I think. In Thailand, they have the same problem. They also have a ring spot virus. It's a different virus, but people in the neighboring countries, scientists in the neighboring countries, have engineered papayas there so that they, too, are resistant to ring spot virus. But they can't grow them officially in Thailand because Thailand is totally anti-GMO. But the farmers just grow them anyway and don't tell anybody. So, there are a number of lessons to be learned from all of this. One of the lessons is shown here. If you don't want to eat food that's been made by GMO techniques or by any other sort of techniques, that's up to you, right? Don't buy them. No one's forcing you to buy these things. You have a choice. We have so much food in the supermarkets, we can pick anything we want. But don't pretend that the reason you're not buying them is because they're dangerous. Just admit it was your choice. You didn't want to do it. And that's fine. No problem with that. But it's also worth remembering that, if anything, GM foods are probably safer than traditional foods. I'll tell you something interesting about organic food. I'm sure many of you go out and like to buy organic foods. If you want to get a bacterially acquired infection, eat organic. The rates of bacterial infections are 10-fold higher than for regular foods. Think about that too when you're making your shopping choices. For developed countries, food is really not a problem. It's easy. But we really must not forget that when we make claims about food or about anything else, for political reasons, for local reasons, or whatever, the world knows about it immediately. And we shouldn't be saying things that are simply not true scientifically in order to make a point locally. We have to realize it will affect the rest of the world, and that's what's happened with the GMO issue. We need more science in politics. We need the politicians to listen to the scientists. Climate change is a wonderful example of this. There really is no debate among 99% of scientists that climate change is real. Climate change is happening, and we're causing it. We're the problem. But do the politicians listen? Well, you know, in most countries they do, but not in the US. But I need to say no more about that, I think. I think there are several points I'd like to make here. So one is that politicians use tax dollars, use our dollars in order to fund scientists to do scientific research. I think most of us would agree this is a good thing. But after this research is being done and scientists reach conclusions, the politicians should listen to them. Why would they not listen to people that they're funding? Okay? If they don't want to listen to us, why fund us? Just stop funding. We have to stop supporting the ideas that foods produced by GMO methods must be inherently dangerous when the science says that they're not. That there just is no doubt that there is no problem here. Think about this. For 30 years, we've been growing GMO crops of one sort and another. We've been feeding people with them. We've been feeding animals with them. In fact, Europe, which doesn't allow their countries to grow GMO crops, they import GMO soybeans to feed the cows, to feed their animals. Billions of tons of these things have been eaten. Have you heard of a problem with them? Have you heard any cows having a problem in Europe or anywhere else? No, because there has been no problem. There's not a single documented case of a problem. And if these were so dangerous, surely we would have heard about it by now. But the bottom line is there is no problem. There's no reason to think that these things are dangerous. The worst of all is this move at the moment by the European Union to try to get a statement in their constitution that would tell the G8 countries that they shouldn't be supporting GMO research in Africa. I find this appalling. You know, if you look at all the damage that Europeans did when they were colonizing the developing countries, and now they're trying to tell them how to behave, I think the time has come to tell the Europeans to go to hell, frankly. Civil society has to play its part too. There are many ways in which we can get civil society to play its part. Groups like the Rotary clubs, groups like religious leaders, influential celebrities, well, that's sort of a mixed bag because, some of these are anti-vaxxers, which is not something that I'm very keen on. But there are celebrities who could speak out, who will say good things here. And finally, I think the media really needs to think about what it's doing when it's telling stories like this. Even these days in the media, when they're discussing climate change, they try to present it as a 50-50 argument. They do the same with GMOs. It isn't. The science is absolutely clear. There is no problem. Now, we've been trying to get, the Nobel laureates have been trying to get the Pope to say something. I met with him some time ago. I'm trying to get to meet with him again. We feel that if we could persuade him, he believes the science. He has no problems with the science, but he's been fed some bad economic facts. And we're trying to get a prominent economist to come and talk to him. But the best thing that has come out of the Vatican so far is this statement. Now, if you're a Catholic, there is a ceremony you go through called Mass, in which you drink wine to represent the blood of Christ, and you eat bread. And this statement appeared in the Catholic enunciations, in which it said, Eucharistic matter, the stuff that you eat in Mass, if it's made with genetically modified organisms, it can be considered valid matter. However, if it's gluten-free, apparently this is bad, this doesn't work. But if it's genetically modified, it's okay. So this is the most promising thing that's come out of the Catholic Church so far. Finally, let me tell you, there are a number of people now who have become converts, that is, they were anti-GMO and have changed. One of them is Patrick Moore. This is the guy who used to be president of Greenpeace who started the anti-GMO campaign in the first place. He is now very pro-GMO. He's advocating for golden rice and saying a lot of good things. Stephen Tyndale used to be head of Greenpeace in England. He's no longer with us, unfortunately, but he changed his mind completely. Mark Linus, an interesting case, he was one of the real strict activists in England. He used to go around burning crops of GMOs. He's changed completely, and now he's a huge advocate. But probably the single most important person is this gentleman down here, Mohammed Adams Nasiru. He used to be head of the Peasants Farmers Association in Ghana. He was anti-GMO like you wouldn't believe. He was going around telling everybody that you had to be anti-GMO. And then he took some time off and learned some science. And now he is totally pro-GMO. He's talking to the government. He's talking to the farmers in Ghana. And actually is having a big impact. A, because he's a local. B, because he switched. He listened to the science and found out what was going on. And it is very important that we get scientists within the developing countries to take the lead on this. It's all well and good for someone like myself to go and talk to them, but really they listen much more when it's the locals who talk to them. And finally, GMO, it's a choice. It's a Western indulgence of the rich. If you look at the typical table in a French restaurant, you have a choice of what you do. But these poor boys in Africa have no choice. They need food, and I think it behooves us to do everything we can to see that they get it. I hope you will all take a look at this website. I hope you will join the Nobel laureates, 142 of us now, and let's see if we can't finally make a change here and really get the anti-GMO people out of the picture. Thank you. Okay.
So thanks, Sir Richard, for the enlightening talk. So the talk is now open for discussions. Will you raise your hand if you have questions? Yes, please.
Professor, I just want to make one point first. I'm for GMO. But as a layman, I think I also have as a layman in biological science, I also have some questions about the genetic method. How does gene does it work discretely, or does it have interaction with other genes? When you add the genes to a new host or new plants, does it have another interaction with the existing genes and produce other undesirable effects?
So the answer is yes, it does interact. The gene will have effects that interact with other genes. But in general, it doesn't cause problems, but it's easy to test. When you do traditional breeding, you face much more difficult situation. Here you're introducing hundreds of genes, and these all interact. And these can cause problems, and we know they have caused problems. There have been many times when traditionally bred plants often end up, they just don't work, they cause problems. There was a big problem with potatoes that ended up being poisonous if you ate too much of them. But you can test all of this. I'm all for testing. But let's not differentiate the testing for traditional plants and GMO plants. And let's not go overboard. You know, what's happened at the moment is it is so expensive to test GMO plants that only the big agricultural companies can afford to do it. And the scientists who are working in Africa, who have very little money, they can't afford to do all of the tests that the anti-GMO people have decided they need to do. So, yes, of course, there can be problems. For instance, you know, there are plants that produce nasty poisons, like sorrelins in celery. You could imagine bringing something like that into a plant and making 10 times as much, at which point it might become dangerous. But you can test all of this ahead of time.
Do they install some safety features such that you will safeguard and such undesirable effect won't happen, or even if you test it, it will happen later, or in some you never know.
Yeah, you know, life is not without risks. Right? All you can do is you test the best you can. You know, people go skiing. Skiing is an accident waiting to happen. You have your accident and then you stop. I think the same is true for food and food safety and for other things. But there's no difference between traditional methods and the GM methods, and whatever rules and regulations you put in place, they should be the same for both. They really shouldn't differentiate between them. There's no reason to think that GM foods are going to be any more dangerous. And also the genes that are typically put in are safe genes. You know, if you were a terrorist, you could put in something nasty. But the food companies have no interest, the scientists have no interest in trying to put in something nasty. They want to try to help people.
And I think if you look at in the supermarket shelves, there are a lot of products that will specifically say it's not GMO products.
Yeah.
I think it's a bad impression
for
people.
Yeah.
No, just an ordinary consumer, and say, oh, that means GMO is not good.
That's right. And that's why the GMO labeling people were so keen on passing this legislation. But interestingly, it turns out there was a study done recently in Vermont in which people were looking to see, do the GMO labels stop people from buying them? And the answer is no. It's had no effect whatsoever. People look at price. Price is what's important.
Okay, any other question? Yes, please. The one at the back.
One up the back there too.
That one first.
Good morning. Good afternoon, sir. Visiting History Museum is opposite to a Science Museum. United Kingdom sold opium to China and start a war. We are ignorant Chinese, and we are fighting all these chemicals to us. We hope scientists have ethics and save us Chinese as other white people. We worry not only food, but also sex and sickness. Animal should be tried and tested first before human. Eating this GMO food. Thank you.
Was that a question?
It's a comment, is it? Okay, this is a comment.
Yeah, that's what I thought.
Okay. So another question from there? Yes. The one at the back, and then this lady. Yes. There's one at the back first.
Thank you for your very informative talk about the benefits of GMO food on the human population. But the question I want to ask is that despite you believe a lot of those anti-GMO organizations are motivated by money or politics, do you believe that there are some genuine concerns about the risk of GMOs on the environment? One point that is often mentioned by the opposition is that GMO may decrease the biodiversity in the environment because the GM organisms are so competitive that they compete with the existing species and decrease the chance of survival. And are they also worried about the risk of causing the appearance of superbugs? Do you believe that these are genuine concerns, and how would you respond to them?
Okay, so I think you will find that there is no basic difference between growing a crop that's been produced by regular methods, by the old traditional methods, and those produced by GMOs in terms of the inherent danger to the environment. Traditional crops have exactly the same problem. You know, they spread their genes around, they spread pollen around, and it goes. But usually, they are less fit than the wild varieties that surround them. And in fact, to get any crop to grow well, you put in the fertilizer, you put in water, you go to great lengths, you use good agronomic practices in order to keep them going. The other issue on the environment is that if anything, GM crops can actually save the environment, because if you can get 4 times as much yield from an acre of land, that means you've got 3 acres that you can put aside for diversity. You can let people grow whatever they want on it. You can let the jungles grow. You don't need as much land then to produce the food. So there is another aspect of diversity that I think is quite important. But in terms of just having these plants grow everywhere and take everything over, I don't think that's something one needs to worry about at all.
Okay, and the lady there.
Thank you for this very inspiring talk. And as a science student, I'm really interested that you have mentioned about the test for many times. So are there some parameters that the scientists usually test for the GM food that if they are safe for people, like if it is poisoned or anything? And the second question is, I've heard about a story that some of the seed of this GMO food is modified, that they cannot produce, they cannot breed offsprings. So the farmers have to buy the seed every time they need to farm. And those seeds are actually very expensive, so not many farmers can actually afford them. If we have to produce this GM food in Africa or some third world countries, is it a problem we need to solve?
Okay, so the bottom line is the second point you make is just not true. If you listen to the anti-GMO people, they love to tell this story. Monsanto developed some seeds that could not propagate, but they got a patent on them, but they have never been sold commercially. And all of the GM crops that are available at the moment, there's no problem. If farmers want to use the seeds, they can. But usually farmers prefer to buy the seeds anyway, because when they grow them themselves, usually they don't get as good a yield, as high, really good fertile seeds as they do when they buy them from the market. So it's very rare that they want to do that. But of course, in some developing countries, they do want to do that. There's no reason why they couldn't. And these things behave exactly the same way as regular seeds do. Remind me again, what was the first point?
Are there any parameters the scientists...
Oh, testing. Okay. So, I mean, the way in which one typically tests whether something is reasonable to eat or not is you feed it to rats, right? And see, is it killing the rats? If it doesn't kill the rats, then you're probably halfway to having something good. You can test on human cells in culture and see, is it killing human cells growing in culture? There are a number of tests that have been devised for this purpose, but none of these, of course, are used for traditionally bred crops. They're only there for the GM crops.
Okay. There is a written question. I just read it out. I have a concern on the GMO. They do sound wonderful. However, I would like to know if another gene from a different species would be added into a genome of a crop, for example. Such gene would be made expressive in the plant. If one having allergy to the protein of the transferred gene, would it cause allergic effect? Would there be tests to test for such potential hazard? May I know if you think it would be better to have a label for warning?
Yeah, so, allergens are always a problem, whether you do it by traditional methods or whether you do it by GM methods. There are ways in which you can test for that if you choose to. Again, with traditional methods, no one ever bothers. We usually find out by anecdotes from people who develop an allergy to something. For GM crops, there are things you can do. But on the whole, most products gluten is a good example, right? So some people are supposedly allergic to gluten and have problems. Turns out that most of the people who claim to be allergic to gluten really aren't. And so there's also a psychological component that goes into all of this. And I think really this is a case where there's no reason to expect things to be allergenic, especially. Let's take the genes from sweet pepper that have been put into bananas. People eat sweet peppers. There's no reason to think that when you take these two genes and put them into bananas, that all of a sudden the bananas are going to become allergenic. It just doesn't make any sense scientifically to think that that would happen. But of course there will be people. People are different. Everybody's different. Some people are allergic to one compound. Some people are allergic to something else. A lot of people are allergic to peanuts. But in fact, we could easily make peanuts by GM methods and take out the allergens. So you have the opposite. Here you have the opportunity to remove allergens, to remove things that people become allergic to.
Okay, question at the very back.
Yeah, thanks for your talk. I'm from Zimbabwe, in case you might want to tailor-make your answer to that, since you've given a couple of examples from Zimbabwe. I mean, from your talk, you really sort of laid out the reasons why the people who are anti-GMO, especially like Greenpeace, like why they are like that. And then you sort of also gave, like, for people, at least within the developing countries, why they resist. I think you gave like fear and also lack of appreciation of science. I'm curious. I mean, I study anthropology, so I sort of like appreciate the complexity of human beings. So I'm not very convinced that humans, especially within the developing countries, the only reason that they are resisting this is because of fear and also maybe lack of appreciation of science. Do you have any other more, at least to me, more convincing sort of reason why these people are more resistant?
So what has happened is that organizations like Greenpeace do not go and talk to the general population. They go and talk to the politicians and to the senior politicians. And I think very often politicians have little scientific background, and it is quite easy to scare people. Greenpeace have spent an enormous amount of money on advertising and developing some very sophisticated advertising to scare people. And once people become scared, it is difficult to reassure them. People are not easily reassured by myself or by other people talking and saying, well, this is all okay. And what happens if the politicians decide something is dangerous for whatever reason, then that becomes the law, and the people really can't do anything. So I think, always you go to the top and try to scare the people at the top. And with Mr. Mugabe in Zimbabwe, that worked perfectly well, worked very reasonably. And, one of the things that Greenpeace often do is to say, well, bringing GMO crops into Africa is just another form of colonization, right? That here's the Europeans trying to bring in things that remotely resemble colonial times. I view it the other way. I think it's actually Greenpeace who are trying to bring European ideas to countries that really need GMOs. And I think this is why I say you should get rid of the Europeans and do what you think is good for your country.
There's a question there, yes.
Hey, hello, Professor. As an economics student, I would like to wondering about, actually, the starving in Africa is not about that they are not having GM food. It's that they don't have the sense of the population control. It seems that since the economic, they have a theory it's called the Mafia's trap. Since that the growth rate of the population is always greater than the growth rate of the supply of the food. Since that they're starving there because people don't have no sense of controlling population. If you produce GM food, then will have more food supply to the children. But in fact, then people will have a misunderstanding that they will thought they can have more children even because they have GM food. But in fact, is that the land cannot afford that loss of population. So finally, it will still cause starving. So I don't think the GM food will help the people to solve the starving or the hunger problems.
Okay, well, we could have quite a debate about this. So, sure, economics is important. Poverty is always a big problem. But most of the people who are poor in Africa are growing their own food in the backyard. They're smallholder farmers. If you can increase the yield of food, then you can do a much better job. The reason people in Africa have large families, and they continue to have large families, is because this is their pension. This is the pension system. When they get old, they don't get any support from the state. They have to rely upon their children. And very often, the children die when they're young. So the death rate of young children in Africa is quite high. So it becomes quite a complicated argument. But I would still say that if you can provide enough food to feed your family, that is a good thing. I think watching your children die of starvation is not something that I would advocate, irrespective of any economic arguments. Maybe you want to advocate for birth control in Africa, right? Maybe you start a movement there.
Okay. Yes. Other questions? Yes, there are two questions. This one first, maybe. Yes.
Thank you, sir, for your lecture. I'm currently studying nursing. You have mentioned that food, the GMO food, is medicine, and I'm wondering your view of about GMO human, because GMO human can modify the gene of a human that they can be immune to certain herbal disease like HIV. I don't know if it is out of topic, but I want to know if GMO food is good, and what about the view?
Okay, so there are two issues. So one is GMO making organisms to feed people to do well. Gene editing in order to improve human health or whatever, this is something that we should do, we will do in the future, but we're not ready yet. When Dr. He decided that he was going to try to modify these two young girls so that they would be resistant to HIV, first of all, it was a terrible idea to do it because the technology is just not ready to be engineering humans yet. Second thing was he did it in secret. He didn't talk to anybody about it. And the genes that he chose to do it were plain ridiculous. right? If you don't want to transmit HIV, there are many ways of stopping it. You don't have to take the 2 genes that he decided he was going to do. In fact, the gene, this receptor for the HIV virus that he tried to get rid of, if you don't have that gene, then there are strains of HIV which will use a different receptor. Okay, and it was just a really stupid experiment to try and do it, and I'm sure he did it because he figured he's going to be the first and get a Nobel Prize for it. Yeah? The guy wasn't even a biologist, he's a physicist. I think it was just ridiculous. If he wanted to do it, he should have chosen a gene that really would have made a difference. There are many genes that we would like to get rid of, many genes that get passed through families that cause problems. But this particular one was not a good one. And it was just a publicity stunt. Frankly, if the guy goes to jail, I think that's rather mild punishment for him. This was not a good thing to do.
Okay,
but in the future, we will know how to do it. In the future, we will, but we're just not ready yet.
Thank you.
Okay, next question over there.
Thank you for your talk. It was very inspiring. One thing I'm interested in is that you said that if we there was a case where the scientists replaced the chemicals, pesticides with the GMO, right? Like after they grow the GMO food, they don't have to use the pesticides they used on the crops before. Like they can stop using them. And I want to ask, is it applicable for all GMO food? Like, are all GMO food can they be modified so that we don't have to use chemicals and pesticides on them anymore? Because you talked about organic food, right? And you said that organic food they are not necessarily better than GMO because they may carry natural diseases and stuff. But at the same time, those organic food they aren't being grown by using the chemicals and pesticides. So I'm wondering if all GMOs food they don't have to use those possibly harmful pesticides?
Okay, so there are three things here. So one is, let's look at the organic farmers first. They do use pesticides. If they didn't use pesticides, there wouldn't be any product. Okay, so they use Bt toxin, this Bacillus thuringiensis toxin, which they spray on the plants, or they just use the bacteria and spray those on the plant. They also use copper sulfate, which is quite a nasty chemical, and they use that in order to kill pests. And there are some other things that they use also, which they claim are natural. So they do use pesticides, just not as much. And the bottom line is, as a result of that, they do not get the yields that you could get from regular plants unless you really spray very heavily with the pesticides they do use. Second thing is, on GMO plants, there are several reasons for making GMO plants. In some cases, it is to make them resistant to pests. When you put the Bt toxin in, this is to kill pests that would normally have them. The other reason for making GM plants is because you want them to do better, produce better yield, produce bigger plants, maybe bigger pieces of grain, as in the corn example that I showed you. So there are lots of reasons why you might want to make GMO plants that have nothing to do with pest resistance, but you can always put the genes for pest resistance. You could imagine putting many different genes into a plant to have it grow better. There's talk about making vaccines in plants so that you could, in fact, just eat, say, a banana and get vaccinated as a result of it. So there are many, many reasons that you might want to grow GM plants and put particular genes into plants. And most of these we will see eventually as soon as governments realize that they're on a losing case here.
Okay, we have to end the lecture at 6 o'clock. So we have the last questions. Any questions? Yes, this one.
Thank you very much for the talk. But I just want to ask, specific to this problem that you showed in PowerPoint, you said one of the solutions to poverty, which comes with Hungary, is the GMO. But however, just want to ask specifically in this part, is GMO really the best way to solve this problem? Because according to some results, it says that many foods in Europe was being wasted, while lots of these foods are even given to the ones that are really in hunger. Is there will be a better way to actually just simply transfer those food that were wasted and just to the ones that were hungry? Would it be a better solution? And the second one is it really enough just for using just these times to find out that the foods are really safe? Will it take actually more than like 100 or 200 years to find any other dangers that can cause the human body? Is it really enough?
Okay. So let's deal with this question of food as medicine. I don't care whether it's GM food or regular food. If you're hungry, food is medicine, right? If you go to bed hungry every night, you do not develop properly, you don't grow as well as you should. It doesn't matter what that food is, you need more food. In terms of GM, what GM can do for you is to take crops that currently have never been improved. You can improve them so that people can grow more and can get more food. And it's all very well and good to say, well, you know, we throw a lot of food away in the US, you throw a lot of food away here. How are you going to ship it into the Congo? How are you going to get it there in a way that makes economic sense? You can't do it, right? People have tried that. You cannot do it. It would be better just to not grow as much here and maybe use the land for some other purposes. But you cannot just redistribute it. In the US, there are plenty of people who go to bed hungry every night, and yet in the US, they grow twice as much food as you need for the population. Right? So why don't they distribute it to the poor in the US? Well, there are many reasons why they don't. To think that you could take that food and get it to the Congo, get it to South America, you can't do it. The logistics just don't work. What was the other question?
About do we need more time to actually to find the
problems? The length of time. So if you want to wait 100 years before you find out whether something is dangerous, what is the point in that? You know? Almost every major discovery that comes along that improves life in some way potentially carries some risk. You probably have a cell phone, do you? Yeah? Do you worry about the cell phone? Do you worry about the danger that it brings with it? Are you aware that cell phones, the screens on cell phones, produce blue light and particular wavelengths of blue light that damage the macula? And if you go and talk to ophthalmologists, you will discover that they are finding people with macular degeneration at a much younger age than they ever used to have. And it's almost certainly because of the blue light being emitted from cell phone screens. Do you worry about that? Should we have waited 100 years before we introduced cell phones in case there was a problem? No. You introduce something, you do the best you can, you discover that there's a problem, and then you fix the problem. Right? And with cell phones, it's actually very easy. You can put a screen on that will filter out the damaging blue light. But I bet you don't have one on your cell phone, do you? Right? You don't worry about it. Why are you not worried about that?
Okay, thanks very much. And I hope that you all have an enlightening afternoon. So let's thank Richard once more.
Thank you.